Okay. Okay. So, ayan, no. So, magandang gabi mga master. So, welcome sa ating session ngayong gabi ito tungkol sa motors and generators, no. So, unahin natin dito ngayon ang definition ng motors, no? So, ang motor ay isang machine na nagko-convert, no, that converts electrical energy into mechanical energy, no. So, if you notice sa inyong chat, so meron diyang merong tanong sa inyong chat, no, poll kung ano yung kino-convert ng ating motor. So, is it electrical to mechanical or mechanical to electrical energy, no? So, yung ating motor is nakasalalay dyan is yung kanyang speed and torque characteristics, no? So, unahin natin yung DC. So, yung speed of a DC motor is directly proportional to the back EMF and inversely as the flux generated per pole. So, ito yung ating formula. Yung N natin, yan yung ang kanyang speed, habang yung K, that is the proportionality constant. Tapos yung E phi, no, that is our back EMF or counter EMF. So that is the voltage produced by our generator, no, inside sa kanyang winding. Tapos yung ating phi naman, so that is the flux generated on the poles. So yung torque, no, so torque is exerted by a DC motor is directly proportional to the armature current, no, yung armature current natin, drawn and the flux generated per pole, no. So kaya meron tayong T. So our T here is the torque that is equal to K, constant of proportionality, tapos I sub A or the armature current times the flux per pole, no. Tapos the speed of a motor, no, yung speed of a motor, it is given by RPM is equal to F. Yung F natin is the frequency times 120. So 120 here is constant over P, no. So sa last natin, if mapapansin nyo sa last nating meeting with talking about sa speed naman ng ating alternator, so parang katulad na ito, no, kasi yung number of pole, no, ng ating alternator is equal din siya sa F. The frequency of our alternator is equals to the number of poles times N, which is our speed, over 120, no. So yan yung ang kanyang formula. So parang sa speed of a motor, so parang binaliktad lang natin konti yung formula, no. Okay, so ngayon pupunta na naman tayo sa types of DC generator, no, DC motor according to connection, no. So unahin natin yung shunt, no, shunt motor. So shunt motor, it is where the field armature windings are connected in parallel across the supply voltage. So this machine is used almost constant speed, no? Kapag constant speed yung required natin, no? Kapag constant speed yung required, so yung ginagamit dyan is a shunt motor, no? So ito yung formula ng shunt motor. So ito yung equivalent circuit niya. So parang binaliktad lang to na shunt generator. No? So for example, ito yung ating source, no? Ito yung ating voltage source natin. Ito yung ating armature resistance. Ito yung ating back EMF or the counter EMF. Ito yung ating shunt resistance at yung shunt current. So if we are going to get the back EMF, so that will just be equal to Vs minus I sub A, which is the armature current, times the armature resistance, no? Kapag kinuha naman natin yung shunt current, so shunt current is just equal to Vs, no? That is the terminal voltage or the voltage of the source over our shunt resistance, no? Then the armature current is just equal to the source, no? The current of the source or the source current minus the shunt field resistance, no? So kung kukunin natin yung current of the source or source current, so that is just equal to the power output, no? Power output of our generator divide the efficiency over the voltage source. Okay, then we have the series motor. So series motor is the field and the armature windings are connected in series across the supply. So ito, so they are connected across the supply. Then the machine is used, no, where the load suddenly comes and go after some time. So if masyadong mabilis yung variation ng load, so ito yung ginagamit, series motor. And where the constant speed is not essential. So if we are hindi kailangan yung constant yung speed, so ang ginagamit is the series motor. Okay, next we have the long shunt compound motor. So the series field winding is connected in series with the armature winding and connected in parallel with the shunt field winding. So yung series field winding natin, naka-series siya sa ating armature winding or sa ating armature resistance, tapos nakaparallel yung ating shunt field resistance. So the same pa rin to sa long shunt compound generator, no? So if we are going to get the back EMF, so ito yung kanyang formula. So Vs equals to armature current times the armature resistance plus the series resistance. So yung kanyang shunt field current, so that is just equal to the source voltage over the shunt field resistance, no? So yung to the source voltage, no? Next we have the short shunt, no? Short shunt. So short shunt compound motor. So the series winding is connected in series with the supply voltage. So ito yung nangyayari. So ito yung voltage, supply voltage natin. So naka-series na yung ating series winding. Tapos yung ating shunt field winding is connected across, no, or nakaparallel sa ating armature resistance. Okay. So next we have type of compound motors according to methods of compounding use, no? So first we have the differential, no? The differential motor. So the series field winding is connected so that the flux produced by it opposes that of the flux produced by the shunt field winding. So kapag nag-oppose yung flux na na-create ng ating series sa flux na na-create ng ating shunt field winding, so that is differential. If cumulative naman, so parang nag-add, no? So the series field winding is connected so that the flux produced aids or assist, no? So di nadagdagan yung flux na na-produce ng ating shunt field winding. Okay, so speed regulation of a DC motor, so pareho niyan sa speed regulation ng ating generator. So we have no load speed minus full load speed over full load speed times 100%, no? So kunyari if you are going to get the speed regulation, no, of our motor, no, Okay, so lagyan ko ito ng formula. NFL over N NFL times 100. So kunyari yung ating no load speed, no, ang ating NNL is equal to 1200 RPM. Okay, so habang yung ating namang full load, no, full load natin is equal to 800 RPM. Okay, so ang gagawin lang natin is i-substitute natin to. So you have 1200 RPM minus 800 RPM over, so full load, so 800 RPM times 100. So we can now get the percent speed regulation, no? So gamitin natin yung ating calculator for this one. Okay, so we have here 1200 minus 800 over 800, so equal to 0.5, no, times 100. Okay, so we have 50%. So 50% ang kanyang speed regulation, no? Okay, so 50% ang kanyang speed regulation. Ang ibig sabihin nito, from no load to full load, so ang kanyang speed ay nag-change to 50%, no? Ang kanyang change ng kanyang speed. Okay, so next we will go to DC motor starting, no? So if we are going to start our DC motor, so dapat meron tayong tamang method, no? Because in starting a motor, mataas yung kanyang starting current that may cause sa ating winding, no, para masunog, no? So at starting, the motor draws a high armature current. So malaki yung armature current dito, no, sa ating kapag nagsisimula pa lang tayo, we are starting our motor. So the reason of this high starting current is the back EMF. So that is the voltage produced by our motor. So at starting, the value is 0. To reduce the starting current, a starting resistor, or in this case ang kanyang ginagamit is a rheostat, is connected in series with our armature winding. So ito, so this is our series rheostat or our starting resistor. So ginagawa to reduce the armature current, the IA start, no? To get the value of R, so ito yung formula niya, no? So we have R is equal to V sub S, or the voltage of the source, over the starting current, no, starting armature current minus the armature resistance, no? Okay, then motor reversion. If we are going to reverse the rotation of our DC motor, no, so it is reversed by any of the following. So either we are going to interchange our terminals, or the terminals of the armature winding, no, yung sa armature, or i-interchange natin yung terminals ng ating field windings, no? So yun yung pwede natin varying, no? Pag-ibahin natin yung resistance ng ating rheostat connected in series to any of the following. So either yung rheostat is nakaseries sa ating armature winding. So, pwede din yun. Or, the rheostat is in series with the field winding. So, this is the most common method. Or, the rheostat is in series with the supply terminals. So, kahit anong method, no? Tatlong method na yun. Okay. So, power starting, no? So, the maximum safest mechanical power it can deliver to the load. So, yan yung power rating ng ating motor. Pinakamalaking mechanical power na kayang i-deliver ng ating motor. So, the formula for that one is P is equals to 2 pi NT over K. Wherein our P is the mechanical power. So, the unit for that is on horsepower. N is the speed of the motor, which the unit is in RPM. Yung T is the torque exerted by the motor at yung K is our constant of proportionality. Kunyari, pag yung ating unit for the torque is in Newton meter, so ang gagamitin natin na value ng K is 44,760. Kapag yung T naman natin is yung pound foot, yung unit ng torque is in pound foot, so we use 33,000 na value for our K. So for example, we have here our N, no? Your N natin is equal to 1,200 RPM. Yan yung ating speed, habang yung torque natin is 200 Newton meter, no? So we need to find the power, no? The power rating of the DC motor, or the mechanical power of the DC motor. So, ang gawin natin, we just substitute the given sa ating formula. So, 2 pi, yung N natin is 1,200, habang yung ating T, torque is 200 Newton meter. So, yung value, yung unit ng ating torque is Newton meter. So, kaya ang gagamitin natin is the 44,760, no? So, kaya yung K natin sa baba is 44,760. At yung answer natin dyan is 33.7 horsepower. So, ito na yung value ng ating mechanical power. Okay, next. So, standard horsepower rating of our DC motor. So, ito yung standard. So, these are the value of the horsepower rating na mabibili natin if we are going to buy a DC motor. So, we have 1/4, 1/3, 1/2, 3/4, 1. So, pinakamalaki na DC motor, no, is 200 horsepower. Okay. Next, we have squirrel cage type, no? Squirrel cage type AC motor. So, nandito na tayo ngayon sa AC motor. Okay. So, there are two types of AC motor according to the construction. So, first we have the squirrel cage. So, the motor consists of aluminum bars located in slots in the iron core and connected to one another by means of heavy cast aluminum rings located on both ends of the core. So, para siyang cage ng squirrel or ng hamster. So, kaya tatawag siyang squirrel cage. Type na motor. Pag wound rotor naman, no? So, the rotor has windings that are connected to a commutator. So, yung ating motor, no, yung kanyang rotor, meron siyang windings na naka-connect directly to a commutator, no? Okay, so capacitor motors, no? So these are a type of single phase, no? So that capacitor motors are single phase motors, no? They are single-phase induction motor that uses a squirrel cage rotor and a stator that has two windings called the main or run windings and the start or auxiliary windings. So, kapag capacitor motors, dalawa talaga yung kanyang winding niya, no, ng kanyang stator winding, the running and the starting, or the main or the auxiliary windings. So, the direction of the rotation is reversed by interchanging the connection of the start or to the run winding. So, pwede kapag gusto nating i-reverse yung rotation ng ating capacitor motor, so pwede nating i-reverse or i-interchange yung connection ng starting winding, pwede din sa run winding.
So basic parts, we have the rotor, stator, in place or brackets. Then we have the centrifugal device. So ito yung nagko-control ng starting at ng run na winding, no? Then the stationary switch, then one or more capacitors. So ang isang type ng capacitor motor is the capacitor start motor, no? So yung starting winding niya is naka-series doon ng ating electrolytic capacitor. So the motor is equipped with a centrifugal switch that disconnects the start winding after the rotor has accelerated to about 75% of its speed. So ibig sabihin, at starting ang susuplayan ng current is the starting winding, no? The starting winding. After nag-accelerate niya yung speed ng ating motor into 75% of its speed, so yung switch, yung centrifugal switch natin is dinidisconnect na niya yung ating starting winding. So kaya yung nagdadala ng ikot ng ating motor ngayon is the running winding. Then you have the permanent split capacitor motor. So a capacitor motor having no centrifugal switch, it uses an old field type capacitor instead of an electrolytic type capacitor. Then you have two value capacitor motors, no? So this is a capacitor motor using two different values of capacitance for the start and run windings, no? So ito yung capacitor start induction run na capacitor run na electric motor. Then we have the repulsion start induction motor. So one of the oldest forms of single phase induction motor, and were widely used from 1930s through 1950s, no? The rotor has standard DC armature winding, a commutator of special design, and a centrifugal mechanism for short circuiting all the commutator bars when the motor approaches its speed. So ang features ng ganitong motor is low starting torque, low starting current, tapos it is capable of doing well on low voltages. So bagay itong repulsion start induction motor in low voltage applications. Most expensive of all the single phase motor. So ito yung pinakamahal sa lahat ng mga single phase motor. Okay. Then we have the universal motor. So it is a series DC motor which is specifically designed to operate on a single phase AC as well as DC supply. So yung universal motor is a series DC motor na pwede siyang mag-operate also in an AC na supply. So the direction is reversed by interchanging the connection of the armature or the field winding. So this motor is commonly used in portable tools such as electric drills, saws, and in some applications such as blenders, mixers, vacuum cleaners. Now the features of this type of motor is it is perfect for high speed application, tapos ang kanyang size is maliit, no? Small in size. Okay, so standard HP rating of single phase AC motor. So lahat ng single phase AC motor, ito yung kanyang sizes ng kanyang motor, no, in HP. So we have the smallest is 1/6 of an horsepower, habang ang pinakamalaki is 10 horsepower. Then we have 3-phase squirrel cage induction motor, no? So ang supply ng ating 3-phase squirrel cage induction motor is 3-phase voltage, no? The direction of rotation is reversed by interchanging any two terminals to the motor winding. So na-change yung ating rotation ng ating 3-phase motor if we are also going to reverse the rotation of our the phase, no, the phase sequence of our 3-phase. So kunyari yung sa unang supply niya, yung kanyang configuration or phase sequence is ABC. Tapos pag di-reverse natin yung ginawa nating CBA yung kanyang supply, so nagre-reverse din yung motor, no? Then we have wound rotor induction motor, no? So yung kanyang rotor nito is naka-wound, no? So it consists of a rotor core with 3 windings in place at conducting bars of the squirrel cage rotor. The advantage of having windings in the rotor is that the wires can brought out through the slip rings so that the resistance can be added, and therefore current through the winding can be controlled. So ito, mas maganda itong ganitong klase na motor if we are going to control, no, to control our motor, especially the current na napupunta sa ating windings. Okay, then the standard horsepower of our three-phase induction motor, either it is squirrel cage or one rotor. So yung pinakamaliit is 1/2 horsepower. So the 1/2 horsepower is usually used in HVAC systems, no? Tapos sa pinakamalaki is 200 horsepower. Then you have the synchronous motor. So the synchronous motor is a three-phase motor, no? Ang kagandahan nito is the voltage, the motor needs a DC to excite the rotor windings kasi the synchronous motor runs at a constant speed, kaya it is sometimes used, or it is mostly used in fixing the power factor, no? Kung gusto nating i-improve yung power factor ng ating system, so ang ginagamit natin is yung synchronous motor. So features, no? Under normal condition, it runs at a constant speed. It can be used to improve the system power factor, no? The standard horsepower of three-phase synchronous motors is 25 yung pinakamaliit, habang yung pinakamalaki naman na rating niya is 200 horsepower. Okay, then we will now go to motor controllers, no? So motor control system, so these are systems that control the electrical energy used to run a motor, and majority of this device is used to control that energy are in the motor controller, no? Okay, so device under the motor control system, so meron tayong dalawang grupo ng device, no? First is the power circuit group. So this component carry the rated voltage and the current needed to operate or run the motor, no? So this device commonly includes disconnect, no? Yung ating mga disconnect switch, the power conductors, so the conductors that is naka-connect doon sa ating motor, no? Or wires, that was fuses, the circuit breakers, yung magnetic contactor natin, then the rigid metallic conduits, the overload relays or heaters, and others. Yung nagko-control naman sa ating power circuit, no, kaya gumagana yung ating power circuit is the control circuit group, no? So these components are necessary on switching power to the motor on and off under certain condition. So these devices commonly includes the start and stop buttons, yung ating relays, no, yung limit switch, and other sensors, no, float switch, process switch, including the indicating devices, no, yung pilot lamps or yung alarms, no, especially if mayroon tayong fault, so may alarm, so pwede gamitin yung buzzer or the bell for the alarm, no? Kasama pa rin yan sa ating control circuit group. Okay, so component of a motor controller, no? So first we have here the contactors. So these are electromechanically operated switch that provide a safe and convenient means of connecting and interrupting branch circuit. So push buttons, so this type of hand switches are two position device operated with a button that is pressed and released. Habang yung selector switch naman, so they are actuated with a rotary knob or lever of some sort to select one of two or more positions. Then the next is the limit switches, which are operated by machine motion. So they are useful in automation and control application. Then we have the control relays, used as auxiliary device to switch control circuits and large motor starters and contactor coils, and to control small loads such as small motors, solenoids, including servo motors, no? To control yan ating control relays, electric heaters, pilot lights, and other relays. Yung pilot lights, so these are used as indicating or signaling device, so it may be a form of a mushroom or a bullet, no? Nakadepende kung ano yung design ng ating pilot light. Then timer relays. So timer delay relays are divided into two general classification, the on delay and the off delay. The contacts of this relay delay on changing the position of some position for some period of time. So it is usually used to delay the changing or the changing of state, no? Kunyari on or off. So ang para ma-delay yung pag-on ng isang contactor or pag-off ng isang contactor, so we will be connecting the coil of that contactor in a timer relay. Okay, so two main types of motor starters, no? Okay, so first we have the direct online, no? So direct online or the DO. Okay, so direct online. So this is perfect on up to, so this is usually used up to 5 horsepower, no? Kapag magpasa ng 5 horsepower, we will have the reduced starters, no? Reduced starters. So how the motor, so meron tayong tatlong klase na reduced starters. So the first is the primary resistance. So ginagawa natin dito is we are reducing the starting current, no, para hindi masira yung ating armature winding. So ginagawa natin is we are reducing the starting current. So the first one is we are connecting a resistance to the winding, no, the armature winding. So ang tawag dyan is primary resistance na controller, no, or starters. Pwede din gagamitin natin is an auto transformer, no. Okay, tapos ang pinaka-common is the Y delta, no, Y delta starter. Okay, so sa Y delta, so it uses tatlong contactor, no, so 3 contactors. Okay, so one contactor for the main, no, which remains stationary, naka-stationary lang siya for the whole process or for the whole duration of the operation of the motor. Yung isa, so also one for the, so isa din siya para sa ating Y, no, Y. Okay, Y contactor, no. So this contactor, ang purpose niya is para ma-configure or to configure the winding, yung winding ng ating motor into Y, no, maka Y. So this itong Y contactor sabay ito sa pag-on ng ating main contactor. Tapos meron tayong isang delta, no, delta contactor. So the delta contactor is nakadepende kung ano yung setting ng ating timer, but usually that is up 5 to 15 seconds. So the Y contactor will turn off, tapos ang papalit is the delta contactor. So ito na yung matatawag nating the running configuration, no. Okay, okay, so I believe that will be all for the discussion, no? So ngayon we will have the practice test, no. Okay, so sa ating practice test, ang mangyayari is I will just be giving the problem or the question, tapos we'll answer. If gusto nyo mag-answer, so you can go on the chat box, no. So you just write the letter of your answer dito sa ating YouTube live stream, no. Tapos may ibang question din na ginawa kong poll, no, na parang naka-poll, so mag-appear din yan sa inyong chat box, so you could also give your answer, no. So if the chat is medyo delay, then you could also maya pag na repeat tong live stream or you will review the live stream, so pwede din kayong mag-answer doon, no. Okay, so maybe I will just flash the problem here, no. So what is the synchronous speed of a 60 cycle 4-pole AC motor? So yung hinahanap dito is the synchronous speed ng ating AC motor, no. Okay,
Okay, so ilagay ko lang dito sa poll yung ating question at yung answer na pagpipilian. Okay. And I will give you some minutes, no, to answer. Okay, so the question is now posted on the chat, no, as a poll. So what is the synchronous speed of a 60 cycle 4-pole AC motor? So you just click, no, kung ano yung answer niyo dyan. Then I will be solving, no, siguro 1 minute, no, 1 minute to solve. Okay, so isolve na natin to, no? So solution. Okay, solution. Okay, so kanina yung formula natin, the N or the RPM yung ginamit kanina. RPM is equal to the pole times 120, hindi pala pole but F, no? The frequency times 120 over the pole. So yung frequency natin is 60 Hz or 60 cycle, habang yung ating pole is 4 poles. So we have 60 times 120 over 4. So yan ang ating RPM, no? So we have 60 times 120 over 4. Okay, so we have 1,800 RPM. So ito yung ating answer. Okay, okay, so next question tayo, no? Okay, so what is the frequency of a 6-pole 1,200 RPM motor?
Okay. So the question is also now posted sa ating poll, no? So you have 1 minute to answer, no? So just select sa options na nasa chat, no? So naka-poll siya, no, sa ating chat box. So just select kung alin yung answer niyo dyan. Okay, so isolve na natin to, no? So we have we will need to find the frequency of a 6-pole 1200 RPM na motor, no? Solution. Okay, so our frequency is equal to the unknown, no? Yan yung hinahanap natin. Habang yung ating speed is 1200 RPM. Tapos yung ating pole is 6, no? 6 pole. Okay, so the formula, so we have formula natin na RPM is equal to F times 120 over P, no? So paano natin kukunin yung ating yung ating RPM, no? Or the frequency. So we have ito, lipat natin sa kabila. So we have RPM times P, lipat sa kabila. So ito magiging over, di pala, yung frequency pa yung hinahanap. Okay. So yung lipat sa kabila is yung 120. So kaya magiging over 120 is equal to F. Yung F natin is yung frequency. So yung speed natin, o the RPM, is 1200. Yung ating pole is 6 pole over 120. So yan yung ating frequency, no? So using our calculator, so i-enable ko muna dito sa screen yung calculator natin. Wala sa screen natin calculator. Okay, so yan. So we have 1200 times 6 over 120. Okay, so meron tayong 60, no? 60 Hertz. So yung tamang sagot is 60 Hertz, no? Or letter A sa ating screen, no? Okay, so next question. So what is the efficiency of a motor which draws 4.5 kilowatt from a line and delivers 5 horsepower? So hinahanap dito is the efficiency, no? So you have 2 minutes, no, to answer. So ipopost ko dito yung question sa ating chat ba, sa ating chat. Okay, yan. Nakapost na yung ating question din sa ating chat box, no? Is as a poll siya na nakapost. So yung kanina na question, so may isa na nag-answer ng 60 Hz, no? So tama yung kanyang sagot. Okay, so let's answer this one, no? So we have yung ating nahanap is the efficiency, no? The formula for the efficiency. So efficiency is equal to the power output over the power input times 100. Of course, the unit for efficiency is percent, no? So kaya nahanap natin dito is the efficiency. Okay, so yung ating power input, so that is the power that is drawn by our motor from the source. So our power input is equal to 4.5 kilowatts, no? Yan yung ating power input. Yung power output naman natin is yung kanyang binibigay or kanyang binibigay na power, no? So that is 5 horsepower. So kapag kinonvert natin to into kilowatts, so multiply natin yung 746 divide 1,000. Okay? So we have 746, no? So 5 horsepower times 746 over 1,000. Yan. Okay, so 3.73 horsepower ang kanyang ano pa horsepower but kilowatt, no? So 5 horsepower is equal to 3.73 kilowatts. So we just substitute that one dito sa ating formula. So we have 3.73 kilowatts. Okay. So we have 3.73 over 4.5. 44.5 yung nasulat ko sa calculator. Yan. Then times 100, no? Okay, so the correct answer is 82.8 or equal to 83%, no? So yung correct answer is letter B, no? Letter B. So may isa na nagsagot, no? Tama yung kanyang sagot. Okay, next question. So the voltage produced by electromagnetic induction is controlled by blank, no? So is it controlled by the AD current, the number of line of flux cut per second, pwede rin kaya the size of the magnet, okay, or the number of turns, no? So ilagay ko muna. Okay. So nakalagay na sa ating sa ating group chat, sa ating poll yung question. Okay, so let's try to answer this one, no? So tamang sagot nito, no, the voltage applied by the voltage produced by the electromagnetic induction is controlled by the correct answer is letter A, no, the number of lines cut per second, huh? So ang amount or the magnitude of the voltage na produce, no, during electromagnetic induction is controlled kung gaano kadami yung fluxes na kakat ng ating conductor per second. Okay, next question. Okay, so we have a permanent magnet use blank as the magnetic material. So ano yung ginagamit ng ating permanent magnet as the magnetic material, no? Okay, yan. So, nandun na yun sa ating live chat yung ating question, no? Sa permanent magnet, use blank as the magnetic material, no? So, ano yung kanyang ginagamit as the magnetic material kapag permanent magnet, no? Okay, yan. So, the correct answer is letter C, no? Letter C yung ating correct answer, which is hardened steel, no? So, if you are going to make a permanent magnet, so the magnetic material is hardened steel. Okay? So, next question. Okay. So, the armature current drawn by a DC motor is proportional to the blank. So, ano yung kanyang proportional sa ating armature current? So, is it the motor speed, the voltage supply, the flux required, or the torque applied? Okay, so may nagsagot na ng voltage applied, no? Okay, so dalawa, no? Ang sinagot ay voltage applied. Okay, so the correct answer for this one is letter B, no? The voltage applied. Okay, letter B. Okay, next question. So basically all electric motor operate on the principle of repulsion or blank. Okay, so is it magnetism, induction, resistance, or capacitance? Okay, so may sumagot na ng induction. So dalawa, no? Yung sumagot ng induction. Okay, so the correct answer for this one is letter B, no? Tama yung induction. So the other term for repulsion is induction. Okay, next. A DC motor are used in application where blank is required, no? Constant speed, high torque, high starting torque, low no load voltage, or none of these, no? Okay, so i-flash ko muna yung question din sa ating chat box. Okay, so the correct answer is letter B, no? High starting torque. Okay, next question. So the speed of the DC motor can be controlled by, so is it by varying the armature current while the field current is held constant, no? Or by varying the field current while the armature current is the one which is held constant, or by varying the armature voltage while the feed voltage is held constant, no? So hindi ko yata makopya lahat ng choices dito, no? Kaya lagay ko na lang is yung letter ng choices. Okay, so the device that serves to govern in some predetermined manner the electric power delivered to the apparatus to which it is connected is called either a switch, control circuit, feeder, or controller. No? So, alin yung sagot mo dyan? Okay, So the correct answer is letter D, no? So controller. So it serves to govern. So ibig sabihin yan, kinokontrol niya yung paano natin dinideliver yung power to a certain apparatus. Okay, next question. So it is used to measure the RPM of a motor, no? So to measure the RPM speed of a motor, you would use a blank. So use a hydrometer, a bolometer, a tachometer, or a odometer. So may sumagot na ng tachometer, no? Okay, so the correct answer is letter C, no? So a tachometer is used to measure the speed of a motor. Okay, next question. Yan. Okay, so a motor with a wide speed range, no, is called a blank. So is it a DC motor, an AC motor, a synchronous motor, and an induction motor? Okay, so may sumagot na ng DC motor, no? Okay. So, isa yung sumagot ng DC. Correct answer is letter A, no? So, letter A yung tamang sagot, which is DC motor. Okay, so next question. A type of AC motor that runs at a constant speed and used for such purposes as an electric clock motor is a blank motor. So yung ginagamit as an electric clock, no? So anong tawag sa motor na yon? So is it a squirrel cage motor, an AC induction motor, one rotor induction motor, no? And a synchronous motor. Answer, no? So the correct answer is letter D, no? Synchronous motor. So yung synchronous motor, it runs at a constant speed, no? Kaya perfect siya for electric clocks, no? So next question is, fractional horsepower universal motors have brushes usually made of blank. So is it copper strands, mica, carbon, or thin wire rings, no? So, meron ng sumagot ng carbon, no? Dalawa yung sumagot ng carbon. Correct answer is letter C, no? Carbon. So, brushes are usually made of carbon, no? Carbon strips or carbon bars. Okay. Next. A type of motor that will not operate on DC is the blank. So ano yung motor na hindi siya gumagana if the supply is DC, no? DC current yung ating supply. Okay. So is it series, no? Series motor, short shunt, no? Short shunt motor, long shunt compound motor, or a squirrel cage motor. Okay, so the correct answer is letter D, no? Squirrel cage motor, no? Squirrel cage. Hindi yan nag-ooperate sa DC na supply. Okay, next question. A large squirrel cage induction motor are usually started at a considerably lower than the line voltage to blank. So, ano yung reason? No? So, is it to allow the rotor current to build up gradually? Okay, so that is letter A na option natin. And letter B, permit starting under full load. Letter C, avoid excessive starting current. Or letter D, obtain a low starting speed. Okay, so the correct answer is letter C. So that is to avoid excessive starting current. So letter C yung ating tamang sagot, no? Next, kilowatt is supplied to a motor and its output is found to be 54, 90 or 100%. Okay, so ito problem solving. So you have 2 minutes to answer. Okay, so let's solve for this one, no? Kung ano kaya yung tamang sagot. So, solution. Okay, so our power input is 45 kilowatts. Then our power output is 54.2. Multiply that one by 746 watts. Tapos, i-divide natin ng 1,000 para itong horsepower is maging kilowatts, no? So, we have 54.2 times 746 divide 1,000, no? So we have 40.43, no? So 40.43 kilowatts, no? So yan ang ating power output. So solving for the efficiency, so power output, meron tayong 40.43 divide time, so 89.84 na yung pinakamalapit sa choices natin is 90%, no? Which is letter, no? So ang tamang sagot is letter C, which is 90. 89.84, no? 89.84%. Okay? So I guess yan na yung ating discussion for this evening, no? With the example, no? If you want to review everything, so pwede naman through after nito mga 5 minutes